Triggered.
Fan.
Turning on the fan at 60% of its speed as the current temperature at your location is 30 degrees Celsius.
Hi, I'm Sai Krishna here. In order to provide technical answers to real-world problems, we have developed this program to take the home automation to a further next level. Until now, you were just able to control smart devices, but now you can control lights, fans, and everything user adaptive. So, you have been thinking by now, in this world of Alexa and Google Voice Assistant, why should I even think of any other voice assistant? But yes, because these all devices are cloud-based and need internet to work. But this device, which we have developed right now, works at the point of user without any internet. So you can call this something like IoT without internet. In order to maintain the privacy at a top-notch level, we are not using a traditional voice assistant procedure, which converts voice to text and then searches for the command. Rather than doing that, we have made a program which can directly read the statistical features of the voice and then predict the command. On doing this, so all your data is secured and nothing gets out of your house. We are not dependent on any traditional machine learning program. For achieving this with minimalistic data, we have trained multiple machine learning programs which run simultaneously, and based on probability, the accurate and precise result will be shown. In countries like India, due to the diversity in the languages used and the accents are really significant, in order to achieve a common platform for each and every one, we have worked on the machine learning program while training the voices from different parts of India to make the end user use this assistant with utmost comfort. To take it to a further next level, we have incorporated the temperature module as well as the time module into this program. This makes us achieve to control the speed of the fans and the intensity or the number of lights you want to switch on. Everything adaptable to your lifestyle. We are able to achieve all this with minimalistic data. So we don't use any cloud computing and everything is processed at the point of service. So this being said, I am now fascinated on how I worked on this program. Come, let's get to it. For basics of machine learning, you can pause this video here and have a look if you would like to.
Collection of data is our first step, which involves reading the data in time domain format and then converting into frequency domain format, which would be done here, where time domain is converted into frequency, and then we extract few features from the frequency domain, which are here. In this case, we are considering kurtosis, the maximum amplitude, the sum of the data points, which would be our total energy, and the standard deviation of the data points. So for instance, if we run this program, fan, so my voice is recorded as fan, and which is shown here as the time domain, and the bottom curve is the frequency domain.
For instance, these are the audio file examples of lights and fan.
So once we are done with these data recordings, we do the same procedure for how many ever data points we want.
This is a screenshot of the data points I collected.
So now we are going to look through the classification learner part, where we can import the Excel sheet which has the data recorded from the voice program which we have seen earlier. Now here it selects the predictors. Here the command and predictors are already been selected automatically. We have two types of validation here. One is the cross validation and one is the hold on validation. In cross validation is basically to train the data thoroughly within itself, for whereas the hold on validation, if you want to forecast the future, you can do that by hold on validation procedures. And once we start session with cross validation session, we can have a scatter plot here by varying the predictors for visualization purpose. And we can select these confusion matrix, ROC curve, and parallel coordinates plot for our future evaluation. And now these are all the available algorithms in the classification learner. Now I'm just going to train all the algorithms and see which one works out the best. Once it's trained, I'll restart the video. Now since all the algorithms are trained, here there are the algorithms with the accuracy in the validation part, and the highest seems to be the 75% accuracy, which is SVM cubic, that is as support vector machines. Here we can see the confusion plot, which shows that out of 10 fan data points, 7 are predicted correct, whereas 3 are predicted wrong. Whereas out of 10 light data points, 8 are predicted correct and 2 are predicted wrong. That's what the confusion matrix is all about. So classification learner is just all about drawing a line of separation between the data points. It might not be between only these two predictors, but all the predictors versus the rest of the predictors. So it's like all together in different dimensions, of course. So for our program purpose, we can select any three of the algorithms. Here we can choose the SVM cubic as number one. And the second one, we can go with the quadratic discriminant procedure, which gives 70%, which is also decent enough. And the third one we can select is the KNN weighted, which is neural network procedure, kernel neural network. In these, when we can export the models here. Once we export, the variable name will be asked, which can be given when we go into the program part. HALFLR, HALFLD, and HALFESKNN is what I named for three of them. And when we YFIT, this is the one which predicts on based on the structure. So basically, the name variable name is in the structure format, and on based on the input given to the structure, it gives the output on this line prediction function. So we create a similar table while taking an input data, the same as the Excel sheet data as kurtosis, maximum peak total energy and standard deviation in the same way. And then we go up with this part of the program is for the probabilistic based analysis, which gives the code with the highest probability. And if two programs predict fan and one predict light, then that is going to give fan as output. At present, for the simplicity of our understanding, I have made the program for adjusting the speed of the fan on the varying of temperature. So here I have collected the temperature data from internet, but in the real model, we are going to put a thermocouple which is going to collect the temperature data and gives to the Arduino, which takes the input, and the program has been processed. So I have put these ranges, but instead of putting range, we can collect the data from the end user by checking out at which temperature ranges what is the operation of fan speed. On based on that data, we are going to follow the same procedure of classification learner to adjust the speed of the fan for user specific. TTS is text to speech basically for the response in speech form. So if the range of temperatures between 0 to 20, it's going to switch on the fan at the speed of 20% of its speed. If it is numbered from 1 to 5, it would be number 1 to 1, 2, 3, 4, and 5 in the same manner based on the temperatures given. For the intensity of the light, we can follow the same procedure for based on the classification learner. But here, for the simplicity case, I have set it on different timings, like from morning 6 to 8. It will be with the intensity of 50% as it's early morning, which will be from text to speech form. And 8 to 12, and these are the temperatures and the intensity I have given according to my will for the understanding of this program. But in the real case, we are going to collect this data from the end user, which will be trained by the classification learner based on the data, and that data will be imported here to check the predicted class. Yeah, that is a part of the program. Fan.
Turning on fan at 40% of its speed as current temperature is between 20 to 24.
Lights.
Turning on lights with 100% intensity as it's midnight.
Thanks for watching this video. The related documents and the linked websites are given in the description below.
Turning off the devices.